back. So now we are going to go over the review for the entire course. There is a small homework collection called Calculus 1 Review. Look at that. There are 25 problems. Now I have to tell you that reviewing 25 problems is definitely not sufficient to do well in your final exam, but this should be a start. Okay, this should be a start. If you have time, in addition to going over the Calculus 1 review, go to your Dropbox where you have all your files. For our class Math 31, you will find final exam review sheet. Okay, it should be here. All right, so when you have time, after going over the web work Calculus 1 review, go over this. The answers to this review sheet are at the end. You will see answers to your review sheet over here. Okay, so go over this review sheet after going over this. Problem 1 has 7 parts. So let's go over at least some of the parts in this particular video. First part for me says, if fx and gx are increasing on an interval I, then f times g, the product function, is also increasing. Actually, it's false. Okay? Just because fx and gx are increasing on an interval I, it does not mean that their product would also increase. Okay? So one thing before I continue with the explanation, always note for a true-false question, it is important to understand each question. Understand rather than just guess. Justify at least to yourself why a statement is true, if you believe it to be true. If you believe a statement to be false, have a counter example at hand. That's what I'm producing now. A counter example. My claim is, if f and g are increasing, it does not mean that their product should increase. Here is a counter example. Consider the function fx equals x on the interval 0 to 2.5. That is y equals x graph. Now shift that graph down. That is my function gx, x minus 5. Okay, shifted graph down. Now notice function g is the same as f, essentially shifted down. What does that mean? From 0 to 2.5, here I have the graph for 0 to 5, right? F is above, whereas G is below the x-axis. In other words, G is negative in my interval. If you look at the product, sorry, x times x minus 5, that's a parabola. And the graph of the parabola is decreasing here and then increasing. So while f is increasing and so is g, right, the product is not necessarily increasing. It is decreasing from 0 to 2.5 and then increasing, which means if I choose my interval appropriately, 0 to 2.5, f is increasing 0 to 2.5. G is also increasing 0 to 2.5. When x is 0 to 2.5, I am increasing, but their product is decreasing from 0 to 2.5. Why would that happen? Look, G is negative. So expect some difficulty when one is positive, one is negative. Expect some strange behavior. Here it's decreasing and then it's increasing, and that's okay. All right. But our claim here, if F and G are increasing, then their product is increasing, is a false claim. A continuous function on a closed interval always attains a maximum and a minimum value. This is a true statement. Why? This is what we call the extreme value theorem, section 3.1. Go over the lectures on section 3.1. Extreme value theorem says a continuous function on a closed interval attains its absolute maximum and its absolute minimum. Okay, on a closed interval attains a maximum value and a minimum value. That is true. Continuous functions are always differentiable. That is false. Why? Here is absolute value x. It is continuous. Continuous means my graph is unbroken, but it is not differentiable. That is, my graph is not smooth. Look, there is a pointed point here. Okay, there is a sharp point here. Whenever your graph has sharp points, that is, your graph is not smooth, your function is not differentiable. So this part is false. Okay, I'll continue with the rest in our next video. Until then,